This is the next one. So next, we're going to sign the certificate, and our admin account is going to set the render server. So here we have the contract created. We're going to sign the certificate. And we're going to query for the render server and show that it's empty here. And these are instantaneous. So whenever we do set the render server with the command execution, we'll see whenever it does update, we're able to get the query instantaneously. So as you see, it's in queue, and we'll query here to show that it's empty for the get render server until a few blocks here, where we have our now have our render server on our local host. Next, we will then send an HTTP request to trigger the render blender and render an image from a .blend file in decentralized storage, but we will mimic that through the local storage that we have for the file ID. So here we've inserted our file ID, and this you can watch as the .blend file will render. And notice that the off-chain worker will not know the contents, and neither will the decentralized storage, because the key is stored in the secure enclave. Here's our file, the PNG file from the rendered image, and then we will decrypt the file and load it to show you the rendered image. There it is there. So with the two technologies that we're using here, here's the secure enclave and the trusted execution environment. We have the CPU level isolation and then memory encryption. And then combine that with the end-to-end encryption with the input and output, and then our access control can be programmed in there within there. So what we do is combine them. So we're able to send the plain text file to the Phala secure enclave worker, where the encryption service key will be there. We will then get returned an encrypted file that we will then send to the untrusted storage service. The untrusted storage service will have a file ID that the Phala secure enclave worker will retrieve and be able to decrypt and then render in the Blender server, in the render service for the Blender. Then the encryption service will return back the encrypted image to the untrusted storage service, which the client will receive. And whenever we send the encrypted image to the Phala secure worker, it's able to decrypt it and return the file image for us, decrypted. So with this, like with fat contracts, we're able to build on top of Ink smart contracts, because fat contracts are an extension of Ink smart contracts. Right here, with the exception though, that we were able to extend the Ink smart contracts with HTTP requests and privacy. So I'll take this to Achim.
Okay, cool. Hi. I'm Achim Schneider, and I'm a smart contract tooling developer working for Parity Technologies. And I'm here today to introduce you to smart contracts in Ink, which are smart contracts which can be compiled and deployed on either on substrate parachains or on Phala's P runtime, where they get executed in some secure enclaves, as was mentioned before. So I'll guide you through an introduction to smart contracts in Ink. Before I do this, let me mention that beyond the team of smart contract development for Ink smart contracts, there are quite a few talented devs. So there are Michi, Hernando, Alex, Andrew, and Robin from the core Ink team, and Andrea, Keith, and Michael for front-end development and product design. Okay, so what is Ink? Okay, actually, before we get to this question, maybe I would like to know, who of you has experience programming with Rust? Some people, okay. Who has experience programming with Solidity? A few more, that's good. So the idea of this talk is a bit to take you up from having some basic background in Solidity. I do my best to also extend this to general programming experience and to guide you to how those principles apply in Ink, because so basically Ink, it's a Rust-based embedded domain-specific language, which is used for writing WebAssembly smart contracts. So this means you're able to write your smart contracts in Rust, and you can compile them, and actually writing them just in pure Rust without any further guidance would be probably quite challenging, but an embedded domain-specific language is a language which is enriched by certain macros. So when we compile the smart contracts, there are some macros, those are instructions to enrich the Rust code with some extra code for some standard smart contract interactions. And so by enriching the Rust code with those macros, you are able to develop smart contracts with Rust. And we will assemble here the best parts from Solidity, and we look at Solidity, we take the good parts, and we kind of reshape those structures and the capabilities of Solidity with Ink and Rust. Okay, so probably, as we have seen, most of you have not so much experience with Rust. So this is just to give you an idea how the smart contract basically looks like. But don't worry, I will explain all the things showing up here in detail. It's just a thing that this would be just some plain Rust code, and actually you would also be indeed able to compile this code, but then you wouldn't be able to deploy it on a WebAssembly runtime where we are planning to deploy our smart contracts. So to make it an Ink smart contract, what remains to do is add those macros, which then gives the instructions to the compiler, like this is a constructor, those are the callable messages, this is the storage of the smart contract. So yeah, the combination of Rust code together with the macros allows you to finally write smart contracts in Rust. So, and then when you develop smart contracts in Ink, probably if you have developed before smart contracts in Solidity, you might, at least for the first tutorials, have written them in Ethereum Remix. You have compiled them, you have deployed them somewhere. So what do you do with an Ink smart contract? Actually, there is a command line utility which allows you to compile the smart contract code. And this compiles the smart contract to a WebAssembly blob. And it also generates the contract metadata. And it outputs those results into a contract file, which contains both of them. And this contract file is what you can finally take, and you can either deploy it on some substrate-based blockchains, which implement as a component the substrate contract palette, or you can deploy it on the Phala P runtime, where the smart contracts get executed in the secure enclave. Okay, why do we want to write smart contracts in Rust? Well, Rust, I mean, it's generally a fancy language and one of the most loved languages for developers, and it can be quite fulfilling and fun to develop in Rust. And well, it has just a very minimal runtime, resulting in relatively small binaries. It has zero cost and safe abstractions. It comes with a whole ecosystem of tooling, which gets available for you when developing smart contracts. And it also is just one of the languages which have first-class WASM support and which are just very suited to being compiled to WebAssembly. So why do we want to compile smart contracts to WebAssembly and execute WebAssembly code? Well, WebAssembly is just a very general VM and bytecode. It has very efficient just-in-time execution, making our smart contract execution just fast. Its formal specification fits into a single page, and it also has a deterministic execution, which is just important for simultaneously executing smart contracts among different blockchain nodes. Okay, so after having seen only Rust code so far, we now get back to Solidity. And what I want to do here is I want to guide you through a very basic example of a smart contract written in ink and compare you like how those things would look in Solidity. So I will actually start with a smart contract written in Solidity. And it's really like a contract more or less as simple as it can get. So probably a good example to start with. So what you see here, it's a flipper contract, meaning the idea of this contract is that you are able to just turn over a coin or like switch a Boolean variable from true to false and vice versa. So what you need to do is you need to store the value of the Boolean within the smart contract. Then if you want to instantiate the contract, you need a constructor to advise the smart contract what the initial value should be. So it would be either true or false. Then you need to expose some functions and make them public. One function to flip the value, so switch it from true to false or from false to true, and one function to obtain the status, like the value, the current value of the stored Boolean. Okay. And now we want to rebuild this logic with ink smart contracts. First thing we have to do here is we have to declare a module. So Rust structures its code in modules, and whenever we want to write an ink smart contract, we need to start with such a module file in which we define a public module with the contract's name, and we need to import the ink language dependencies. And then here you see the first macro, and it's just the instruction for the compiler that this is actually the beginning of a ink smart contract. So, and then we want to store the status of the smart contract on chain. And so this is a general structure of every ink smart contract. It needs to have exactly one storage struct. And the storage struct contains all the data which is supposed to be persisted on chain. And it is annotated by ink storage. Okay, cool. So we define the storage struct, which is carrying the state of the smart contract. And we add this to our smart contract code. And then the next thing is about the constructor of the smart contract. So every Ink smart contract needs to have at least one constructor. Constructors are always annotated with Ink constructor. And there's one thing where Ink differs from Solidity. Actually, in Ink, we are able to allow for constructor overloading, which we do here in this case. So actually, we define two constructors. One constructor which can receive an init value. So, and a second constructor which just instantiates the construct with its default value, and the default value of a Boolean then in this case would just be false. Okay, we can add this to our smart contract code. And then the last thing which remains in the smart contract is that we want to expose the methods which we are then able to call from the smart contract. And there were two messages, flip and get. And yeah, this first message you see here that it doesn't receive an argument, and it doesn't return an argument. It just operates on the local storage of the smart contract. And actually, Rust is always very explicit, which also makes it very aware of the things which are modifiable or not. If you think about smart contract security, this might be a thing, because we need here this message to explicitly not only access the state of the local struct, but we also have to allow to mutate it, right? And if we don't add this mute, then we are not able to mutate the storage of the smart contract. Messages are always annotated by Ink message. And yeah, before I go to the next step, here's the second example of the get message. This message actually will not be able to mutate the smart contract storage, because it only obtains a reference to the smart contract storage, but not a mutable reference. But here in the function definition, we see that actually it returns a Boolean value because we want to read the status of the smart contract. So, and if we add this, then we are arrived at yeah, it's the complete example of our very basic smart contract in Ink, the flipper. And yeah, it's great. That's the complete example of a very basic smart contract in Ink. And then we can go back to the Solidity example, and we can compare like how we define the storage in Solidity and in Ink, the constructor and the methods. Yeah, and the thing is, like, there is a bit more code in Ink, but it's also really much more explicit in defining what you're allowed to do or not to do. So, okay. And so at this point, I would just go over and I would just do a demo of this smart contract, and I will just deploy it on a local node. So actually, one nice thing about Substrate is that, also about the Substrate contracts node, is that we can just start a local copy on our machine. And actually, I just started a local Substrate blockchain on my computer. You see it starts producing blocks, and I will be able to communicate with it and deploy the smart contract on it. And then the Flipper smart contract here is already available. Actually, if you just go to the provided materials and you install like the toolchains and cargo contract on your local computer, then you will have cargo contract as command line utility already available. And then if you just want to play with the contract by yourself, you can do this. You can just say cargo contract new flipper, because the contract which I was just guiding you through is just a boilerplate standard smart contract, which we provide as an initial example, something like if you're familiar with Create React app, that's some very basic standard thing to get started, which you can then start to modify. So I now recreated it. I can go into it. I will also open it in Visual Studio Code, but you can see here that this is the code I was just discussing, and I can actually build it. When it compiles, compiling it the first time, since there is nothing cached, can take 20 seconds. So while it is doing this, let me just open it. So here we are. This is like the standard Flipper smart contract in Visual Studio Code. It takes a few more seconds to compile. While it's compiling, let's just go to polka.js apps. And here in polka.js apps, if you're familiar with it, it's a standard front-end interface provided by Parity Technologies to do a lot of communication with substrate-based blockchains and with Polkadot. And if you just open it in the browser, actually, no, the internet here is not so fast as promised. Okay. Here you see, by standard, it will probably be connected to some Polkadot chain over some RPC node, but I can just connect it to the local node. And here, actually, you see this is my local IP address. This is actually now indeed connected to the local constructs node, which I started a few minutes ago. And so while I did already connect to it, I see here that it's still compiling, but probably not that much longer. And after the first compilation, when you edit the smart contract and you want to recompile it, it will just take a few seconds, like 2 or 3. First compilation always takes a little bit longer. Actually, it's also accessing the internet, so it might also be the Wi-Fi connection, but it's coming to an end, 170 of 184. While it is doing this, there's maybe one last thing which is remarkable, which I can show you. Those okay. No, of course, it's also compiling then. Okay. No, but now it's done. Let's go to the developer contract section of Polka.js apps. And here I can upload and deploy the smart contract. I choose if you start the local node, it comes with some developer default accounts, and you can just use one of them. And then I go here, I go into the Flipper contract, and then within the target folder, you will find the contract file, which I was mentioning before. You can upload it. Yeah. Yeah, and now I was mentioning those two constructors. you can choose one of them for the deployment. Either the new constructor, which allows you to define an initial value, or just the default constructor. So we can instantiate the contract now with initial value being false, and deploy it, sign and submit, and you will see that it compiles. That it instantiates on our local node within a few seconds, and that it's actually deployed. And here it shows up showing the two callable methods, and actually that's some new feature of Polkadot.js API, Polkadot.js apps, that actually the get method is evaluated automatically. So the current value of our Boolean in the smart contract is false, and after calling the flip method, it flips and it should switch to true. Like I signed and submitted the contract call, and now it executed, and you see that the value actually did switch to true. Yeah, and that's basically it for smart contracts in Ink. So if you want to play around with it, just I think you received the link to all the materials. Just feel free to start with Cargo contract new, open the Flipper contract, play with it, and in the Ink repo you will find just a big, like quite a few other more advanced smart contracts like ERC20, ERC721 example, and many more. Yeah, okay. Before we go now over to see what else we can do with Ink smart contracts and Phala's P runtime, are the questions?
I guess I have a question.
Yeah.
Can you help me understand that is Phala just conceptually a type of Polkadot chain that has additional features, or just so I can kind of conceptualize it?
I mean, I can try to answer, and then probably you can add more to it. So Phala actually, they are parachain.
Yeah,
but the smart contracts are executed in a different way. They are not executed by all the participating new nodes simultaneously, but they are executed off-chain by some secure computation enclave, which is provided by the Phala miners.
Yes, and then what exactly was the question again? Sorry, I was trying to.
I guess just understanding the secure execution that's happening on Phala. These are Rust contracts built in Polkadot, but these contracts are extended. Like actually, if you use Phala, is it an extension of the Rust contracts, right? I can actually call out do service calls, or like where does the more open computation that pretty Phala do service calls and like out of chain network operations? Am I understanding?
Okay, yeah, so they are an extension of Ink smart contracts that are running in the secure enclave workers, and they are able to send HTTP requests right now, but like these are more advancements that are coming in the future. So right now we can just send a GET request and get some information back, but we're slowly developing to have more use cases.
Okay. Yeah, we should switch back to the slides, right?
Yeah, I think we're going to do it for a little.
I think I'm done. So. Yeah, there are some links, but yes, this is okay.
So if y'all want to talk to our core devs like Hong and Shelvin, they're ready to answer any questions. So if you just scan this QR code, you'll be able to get to the I think it's Dory app, application to be able to ask some questions, and they'll be able to provide you some really in-depth questions. So maybe if we're not able to answer any like really deep technical questions, they'll be able to get you the right answer. So the next, I'll do more of the hands-on demo for sending an HTTP request. So I know there's not a lot of Rust developers here, but has anybody worked with Phala before for any of their FAT contracts? Okay, cool. Well, let's move forward. So for our like FAT contract resources here, this will help you get your dev environment prepped. So I'll end up going to this link in a second. And
Quick question, I may have missed this earlier. That contract, is that just an identifier, distinguisher, like this contract that can already do certain things? I don't know, only functions in this manner, or is there anything else to know about a FAT contract before getting into this?
Oh, okay. Yeah. So like FAT contracts are, so there's the traditional smart contract that we have today, and FAT contracts aim is to go beyond what a smart contract can do. So giving you more computationally intensive applications, but in a secure way by executing in their secure enclaves. So that whenever someone wants to come and develop on top of Phala, they're able to build whatever applications they want. So you give the developers a little more freedom. And that's exactly what we're working on after.
Thank you, brother. Appreciate it.
Thank you. All right, so the first part I'm gonna go over is just showing you, so for attending this, we have deployed a testnet and we have a way to redeem the POAP. So I'm gonna show you how to do this real quick. And the way you do this also is by having an attestation that's gonna be verified on GitHub's gist. So like gist.github, if you, I'll show you just how to do it, but one second here. Are you on, is your GitHub pulled up on this?
What?
Your GitHub?
My GitHub?
Mm-hmm. Like, I guess I could. Actually, I can send it to mine. Yeah, I can do that. I can.
So, you mean Git? You want to create a gist, right?
Yeah. I can send it to mine.
No, but I mean, shit. Yep. Will be available in a second in a different browser. 1 second.
So I can send mine.
I think I'm kind of. Okay, yeah.
It's part of it.
Mine disappear. Did you mention?
Yeah, I got it.
Okay, good. Good.
Okay, so I'm gonna step you through how to claim the POAP now. Let's see. So here is our front end application that we've deployed. Here's the redeem POAP. I was going to reject Kerber, but
Yep. You can just close it.
and then I'll do this one.
Yeah.
Okay.
That should be fine. Cool.
All right, and from the slides, here we have some in the ETHDenver repo that we have in the previous slide. We'll be able to set the substrate endpoint here. And then we'll choose a P runtime endpoint, and it'll be like either 1 through 5. I'll choose 1 here. Contract ID.
Does that last end variable have any significance?
That's in
That end equals 1 through 5?
Yeah, so these are the different deploy workers that we have for our testnet. So you can use any of the 5. We have 2 different ones. So there's going to be like the other testnet POC 5-2. And then we'll get the ABI from the link. Let's go. And this repo will be right here. So you click on the compiled metadata.json file that we have pre-compiled here, and you'll just copy this. So next, I'm going to show you how to create a test account on the Phala testnet, and then use the faucet account to send yourself some testnet tokens. Right now, we're going to show you how to add that faucet account to your polka.js extension, but just don't abuse it, please. All right. So as we saw earlier, the substrate now contract here. So what you're gonna venture over to test networks, go down, and you'll select the Phala POC 5. And then switch over. All right, the next steps, we want you to create a test account here. So here you'll want to save your mnemonic seed phrase for your test account. You don't want to share that to anybody, but this is just for creating a test account here. You'll say, I saved my mnemonic seed safely, go to the next step. And for this step, make sure you choose before, like you may have like the Phala POC5 network on there, but choose allow use on any chain first, just in case if it doesn't show up. So like a test account, we'll call it fat test. Now we have that test account added, and then we're going to import the test faucet account. And whenever you go to the fat contracts repo, you'll be able to find the mnemonic seed phrase for that. So come in here on the extension and then import account from pre-existing seed. And we'll call it fat faucet. So now that we have these two accounts, we're going to facilitate a trade or a transaction so that your test account gets some test tokens. So as you can see, there's a warning. We'll have to update the fat test account so that they'll show up in the Phala testnet. So you'll go in here. And let's see. Oh yeah. Update. Forgot you gotta update your metadata.
Just close this.
This one. All right. So you're updating the metadata for the extension so that the Phala testnet will show up whenever you're doing that dropdown to add to change your account from use on any chain to the Phala testnet, so that you can do that transaction to get the test tokens from the faucet account. And since we updated it, it'll show up here. So before it wasn't, and now it's here. All right, so we're gonna refresh this page. And then we'll have these two here. So what we're gonna do is send from the fat faucet to the test account. Now the transaction has gone through. So now we have some test tokens so we can claim our POAP. So in here, we'll go back and we'll load the contract. Actually, we might reload this. Do that test. These should be good. Hit the load contract. So the contract is now loaded successfully, and we're going to sign the certificate. So now our certificate is signed. So the next step, we are going to add a gist on GitHub and enter this address here.
Sorry, Josh, what's a gist?
A gist?
Gist.
Yeah. Let's I'll show you right here. So the gist is just like a little text file that you can enter real quick. So I'll show you what I actually have here. So when I ran through this earlier, I created a gist here, as you can see. And this right here is the gist. So this is going to be here for the HTTP request to be sent to the gist on the GitHub link. And what's going to happen there is we're going to verify that is there so that you get assigned your POAP. So you're going to click here. You're going to go to the raw, and this will be right here. So you want to grab the link here.
So the gist is like your identity provider to be like.
No, it's just a file. It's just a file. Just a gist. Yeah, you get the gist. Yeah. No, I was yeah.
Boy, I didn't get the gist.
Yeah. So we copy that here, and we'll insert that link to right here, and then we'll hit verify. I wonder if it changed it from the past. So now it's sending the request, and it should, if it returns, then it would populate the get POAP redemption code. However, let me see if this is different. Let's read this update. Ooh, yeah, I need to create a new one. My bad. So you would go in here, click that copy text, and then insert it here. You can give it a description if you would like. And you want to make sure that's public. Here, and then the raw. Then run the verify. apologies, it won't work. Hold on a second. Sorry, guys. Excuse me?
You said you're getting CORS errors on that page?
CORS errors?
Lots of word changes.
You know what? Just move. Okay. So, unfortunately, that's not working right now. So I'm just gonna show you how to actually upload the code from a compiled contract, then instantiate the contract, and then deploy the front end so you can interact with the contract and have the same thing here. And then there will be, like in the code base, there will be some to-dos so that you can implement access control and then prevent a double redeem. So let's get started. So here's the little ETHDenver reference links. And here's the that contract repo that you'll need to throw in. Excuse me? Oh, yeah, okay. Is it, do I need to use, I guess I can use that, never mind. Use some, and now we have the fat contract repo clone. So we're going to do we're going to build the contract. So I'm going to open up Polka.js, have one tab on the Explorer to just show some of the things going on. I have one for the chain save for doing some queries against the Phala fat contracts. And then we'll have the extrinsics here. So first we're going to upload the code. Let's check on the violation. Once this is compiled, we'll be able to get the .wasm file to be able to upload the code to the Phala blockchain. All right, so almost done. Right now we have the compiler contract. So what we're going to do is upload the code in Polkadot.js. So here I'm just going to show you I'm going to keep this open with the Explorer so we can see the recent events. Sorry, and we'll choose the WASM file. And use the VLHS account, Simon Smith. So now that this is in block, and we can see here that the code was uploaded. So I'm going to copy this here because then we're going to instantiate the contract. So next we'll stay in the extrinsics under the developer tab, and we will then instantiate contract. We'll select the WASM code here, and from that upload code here we copied, we'll then add that here. And then we'll go to So we'll go to on the page here. Since the code hasn't changed, here we should be able to use. Let's check the metadata.json file just in case. So we'll take this selector here. And insert that here in the data. Here you can just choose whatever you want. I'll just, for the salt, so I'll just do 1, 2, 3, 4. And then you'll need to choose a cluster. So since the first cluster we were testing out, we'll choose the second cluster, but let's just check and see how many clusters there are. There's 2. So then we'll look at our cluster workers. So this will be under your chain state, so you can get your cluster workers. And then you can see that we have a bunch of workers under the second cluster so that you can deploy your own redeem POAP. Here. It should be good. So this is in block. And then we'll check over here and see that the different events that are happening during the instantiating of the FAT contract. So right now it's in instantiating, pub key available. Now it's instantiated. So we'll be using this as our contract ID right here. So this top one. And then we'll start that off for a little bit so that we can now deploy our front end. And you can get the front end link here within the VAT contract repo, and you want to make sure that you choose the ETHDenver 2022 branch. So I'll speed through this. All right, then you want to go into the JS SDK and build it here, Yarn. Change over while it builds. Check some things. And then to deploy the front end for the POAP demo that we had saw earlier, you want to run yarn dev. This will deploy your front end. So here at the localhost port 3000. Here we'll click on the redeem POAP. Oh, yeah, I think it's like, there it is. So we go through same steps. Let's see. So I'll click on the fade test. another contract ID, and then we'll use the endpoint and the p runtime URL. Nope. Done. And we'll come here and click one of the off-chain nodes, pick 3, and then we'll get the ABI data from the compiler contract, from the metadata.json. Enter that here, then load the contract. We'll send a certificate. And now we have our own local test front end to do the redeem POAP, except this has some implementations that aren't done yet, just for you to figure out with the access control and the double spin problem or double redeem problem. But here I'm going to show you just an example of how to do a redeem. So as the admin, you'd be able to set a code. So we could say fat code here, copy this, create a new gist, make sure that's public, create it. Okay, so now you'll have a code. I'll have a code to populate to give once we verify the attestation. And there it populates with the fat code that you get in return. So that's just like how you would deploy your how you would compile your fat contract and then deploy your front end, and then be able to run the redeem POAP. And here I think I added the wrong contract ID. So going to verify here from the example that we're getting for whenever you want to claim your POAP. And then you'll get a return with POAP and factory check in 7 days. So that will be the code that you should get. So I'm the third person. So there's 2 other people that have already redeemed a code. Are there any questions right now so far?
the inputs to the application, it stops loading. That means like data.
Oh, right here,
Yeah.
the data. So in your metadata.json file, you'll go in there and see it's, look at the docs. So in your constructors, you'll see this selector. I'll zoom in here, and you'll want to enter this value for your data. And then this all can be anything that you would like. And then so for the development environment, make sure you use this cluster too. Which you can find that here whenever you run a chain state query for Phala fat contracts and query cluster workers. And then it'll show you that cluster right here. Okay, let's see. So after, so now that you have some tools, just please reach out on Discord, or you can reach out to me personally, and I can help you with any kind of deployment or running some of the tests in whichever IDE you use, and kind of give you some information on what needs to be resolved. There's also a branch in the Fat Contracts workshop that is called ETHDenver 2022-solution. After you get comfortable doing some of this development, we are having a little hackathon where the prize is an NFT. Like the top prize would be a NFT for Phala World and some Phala tokens as well. And then other prizes will include a whitelist spot to get a Phala World NFT. So, if you want to learn more, here's some links. And thank you for attending the talk. Have a question? Oh, this is that. Oh, okay. Oh, yeah. And if you want to cut the steps for getting a poke through the front end, you can just scan this QR code and you'll be able to get your POAP. There's two of them. And if you're able to do the one in the front end, you get another POAP that will be here, be given to you for redemption in 7 days. Are there any other questions? In a week, you'll come back with your code. So the little code that you get from doing the front end redemption, and then we'll direct you to a site so that you can insert your address and get your POAP.
I might have one general question about self-execution enclaves. So you take the computation off chain, you kind of execute it there, and then you bring it back to the chain together with a proof of execution. How much effort is it to replace Intel S3X by some other trusted enclave, or maybe also by some other concept like zero knowledge proofs? Or like, how are you working on this?
Yeah. So the way the architecture is, we've made it to where we can handle new developments to support future trusted execution environments, and then also have infrastructure in place so that we could do zero knowledge proofs and MDCs potentially. So,
how far away are you from it?
Well, I'd have to check with home, but yeah, probably somewhere like towards over the next year.
Saw in the, one of the instantiate contract restrictions, there's an option for, WASM code and native code. Is it possible just to
Yeah, so the native code, I believe you would have to deploy your own local testnet so that you can compile your native code contract to do a little more functionality, but it wouldn't be like an ink-based smart contract. It'd be just within the Phala blockchain. If that makes sense.
Okay, it sounds like I can run native code from some arbitrary.
Yeah, I'll have to get verified by Hong and Joven, but if you ask that question in the Dory app, they'll be able to answer that fully. All right, thank you. Yeah.